So in last class, we looked at how we can build a neuron class, and we understood how the weights and biases are related to a neuron. Uh, we did the majority of the work in the last lecture, so let's try to understand the layer class now. So a layer can be thought of a collection of neurons. So for example, in the last class, we built these neurons, and today we will be trying to build this class that encapsulates all those neurons. So let's start by building a layer class, and a layer class will have a public construct. Basically follow the same footprint how we did it in the neuron class. So we started by building some data members and then this constructor and some operators and some operations that we will extend in our layer class. So let's first add a data member, and the data member will be a vector of neurons. So as I just described in the illustration, a layer can be thought of just a collection of neurons. So that's what this is right now. And then let's build the constructor. And the constructor will be pretty simple. We just need to know how many neurons we really want in our layer and what is the dimension of the neurons. So if you remember, each neuron contains a set of weights and biases. So we also need to know what's the dimension of the neuron itself and how many neurons a layer will encapsulate. So the dimension of the neuron, we will just call it dim, and I'll just actually call it dim of neuron. And I will also initialize another parameter that I will call number of outputs. So actually, I'll just call it probably num. Yeah, num output is fine. And I will also take in an activation type as a parameter. Okay. And let's try to fill things up. So of this, let me do num neurons. So we need to initialize num neurons in this layer, and each neuron has to be a size of dimension of neuron. So let's do a simple for loop, and I will just say for id equal to 0 and id is less than num neurons, and let's just go to for loop, and I will just say this neurons. So we just need to fill those neurons, and I will just say in place back, and we need to in place back a neuron. A neuron takes a dimension, so I will just pass in dimension of neuron and an activation type. So with this, I will initialize all the neurons. So this is how my constructor gets created. So that's the first function that we need. Second thing is we need to overload this operator so that everything just works. So what I will do here is I will just add some code, and I'm just copy pasting what I had for neuron, and I just made few changes, and I can just walk you guys through it. So it will take some input here, right? And what it will do is it will first of all reserve the output. So if we go back, the output of a layer, this is the output of a layer. So if there are 3 number of neurons, the output will be 3. So that's what I'm doing here. I'm reserving the output size. And then for all the neurons, I am just calling the parenthesis operator to that input. So let's say that X, destroy it here. Let's say X was our input here, right? So I am basically using this X value for this neuron, and for this neuron. And I'm calculating this output. And I'm pushing that output. So that's what I'm doing here. Yeah. So in output, I'm just adding that output from the neuron. And then I'm just returning that output to whoever is calling the layer class. And we will discuss who calls that layer class. And then we also had some function to, I think, zero the gradient out. I will just copy the same function here. And what this function will do, instead of calling all the weights, it will call all the neurons. So the neurons, I can just delete this. And it will just call neuron.0, right? So this will, like for every neuron, it will make its gradient 0. Okay, so that's another thing that we already accomplished. Other functions that we might need is, for example, printing the parameters of a layer class, like we did it in here. And it's also pretty straightforward, but I have already written that function to print it in a pretty format. And it's the same concept. For every neuron, we will iterate over all the neurons, and we already created this parameter function for neuron. We'll get that parameter and we will push that to this vector. Actually, this function doesn't print it. It just retrieves the parameters, but it will be used shortly. So this function just gets all the parameters. And this is the function I was talking about that pretty prints it. It gets all the parameters and it just prints it. So all the parameters, and you can see everything follows a kind of recursive rule. So for example, a layer class will call the neuron class parameters. A neuron class parameters will then call the value class parameters. And it keeps on going like that. Okay, so I think we now have most of our functions for a layer class and we can test it out. So let's say that you have a layer L1 and a layer L1 takes num neurons. So let's say that you have 4 number of neurons and I need output to be 2. So I need a layer of dimensions 4 by 2. And activation type, let's see. I'll just default it to, if nothing is provided, to relu for now, so that we have this. And let's try to print this, right? And see what do we get. So let me compile this and yeah, let's see. So there are few errors. I found some errors of some imports that were missing and just few minor errors. So I corrected those so you can grab the latest changes. You should be all set. So, okay. So I compiled it and there should be out. Let's run this. Okay. So you can see the number of parameters would be 10. Okay. Let's calculate it. If we have a 4 by 2 layer, that means there will be 2 number of neurons and each neuron will have 4 weights. It will have, let me try a different layer. It will have 1 weight, 2 weight, 3 weight, 4 weight plus bias. So 1 bias. Similarly, 1 weight, 2 weight, 3 weight, and 4 weight, and 1 bias. And this total will be 5 plus 5, that will be 10. So that kind of makes sense. So I think all the calculation checks out here. Let's see, what did we get here? So we got some initial data initialized in those neurons, and the gradient is 0 because that's how we initialize the gradient. There are algorithms in which you can initialize the gradient and say, okay, so there are algorithms in which you can initialize the gradient in a random way, which gives you better results. So I have not implemented it, but of course you can do that. Okay, so I think we have all the building blocks for a neural network. As an exercise, I will encourage you guys to use what you have right now and build a real neural network. I can assure you guys you have everything that you need. You just need a wrapper class that creates a bunch of layers and creates a neural net. The next lecture, we will be working on building a real neural network, doing real training, and getting real results using just one C++ file. And after the end of that lecture, you can do whatever you want with it. You can build complex neural networks. You can use it in your projects. You can deploy it to a Docker container, make requests, get results. The uses are endless. And I hope that you guys watch all the lectures till today, so that when we start working on the next lecture, you are not confused and you have all the basics cleared and you can see all the building blocks coming together and creating this beautiful neural network. See you guys in the next lecture.